So before we get started, I just want to go over a few things. First of all, I'd really like to thank my colleagues at the University of Minnesota for partnering with Angie and I to help pull this off. We really could not do this without the help of Phyllis, Liz, and Lisa, as well as all of our presenters. I'd also like to give a huge thank you to our sponsor for today's webinar, the Iowa Corn Growers Association. With their support, we are able to offer these for free, and then we're also able to put them up online so that others can view them later. So we really appreciate their support of Iowa State Extension and the University of Minnesota Extension. You can learn more about membership for Iowa Corn Growers Association by visiting www.iowacorn.org, and then it's a /join. Hopefully you saw that in the pre-show. Just for a few details before we get started, I'm going to put a bunch of information in our chat box, in particular for CCAs who would like to self-report CEUs for attending today. I'm going to put a link with some more information about how you can do that so that you can get a half credit of pest management CEUs. We also have this really handy Q&A box. So if you look down kind of at the center left of your screen on that taskbar in Zoom, there's a Q&A box. Please use that to ask questions of our speakers at any time, and then I'll moderate those questions at the end. If you have technology issues or any other questions, please feel free to direct those to our panelists in the chat box. We're also going to have some associated resources for this presentation that will be in our box account, and I'll put that link in the chat box as well. With that, I would like to turn things over to our speakers for the day. So we actually have two speakers, and I'm really grateful that they were both able to join us. Alison Robertson is our Iowa State University Extension Plant Pathologist, and we also have Dean Malvick with us, who's the plant pathologist for the University of Minnesota's Extension. So Alison, if you'd like to share your screen, we can get started.
Good afternoon, everyone. Thanks very much for joining us. Thank you to Megan for the introduction, and thank you to Iowa Corn for supporting this webinar today. So today, Dean and I are both going to be talking about TarSpot. It's going to go really quickly. We have about 10 to 15 minutes to talk about identification and in-season management, but hopefully that'll leave 10 to 15 minutes at the end for your questions. So please feel free to ask any questions that you have. This map is a map that was put together at the end of last year, which shows where TarSpot has been reported in the Midwest and also in Florida. And so you'll see that TarSpot was first reported in 2015 in central Indiana and central Illinois. And since then, it has expanded across the Midwest. The yellow counties show where the disease was found in 2019. In 2020, the disease is already being reported in Iowa, Wisconsin, Indiana, and Michigan. I almost said Ohio. And this map was updated 1.5 hours ago. So it's a really good place to go to see where TarSpot is being reported. And I have the website down there at the bottom for you. And on the final slide, there'll also be a link if you didn't get that here. How do we recognize TarSpot? Like any disease, we're looking for symptoms. And the symptoms of TarSpot are these small, black, raised spots predominantly on corn leaves. And the spots may be circular, but they can also be kind of irregular in shape or kind of angular. And I'm going to, TarSpot can get mistaken with a couple of other things that you see on corn disease leaves. And so I'm going to talk a little bit about that in a moment. So we're going to focus more onto those spots. Occasionally, you can also find TarSpot on the husks of corn. In Iowa, I think I've seen it on maybe 2 or 3 husks, literally. And that was right at the end of last growing season. And so I suspect that it gets onto the husks when we get earlier infections and also when we have more severe infections in the field. The other thing about TarSpot is sometimes you'll see what we call fisheye lesions. So you can see a close-up there on the left. basically what this fisheye lesion is you have the tar spots, the black spots, those raised spots, but around those raised spots, you also had this dead tissue. And so that kind of gives those spots the appearance of fisheyes. There's some talk about that may be another pathogen involved with that, but that is the subject of research going on across the Midwest with folks who are doing the research. We know that with tar spot, if you get very severe infections on the leaves, that will lead to premature senescence of those plants. And so in 2018, we heard horror stories of fields in Michigan, for example, where they found tar spot and 10 days to 2 weeks later, the whole field was just dead. The infection was so severe and the plants just died. And then remember, this is a foliar disease. And so as we often see with foliar diseases, stalk rots can be a secondary problem that occurs to, around about harvest. And while you're waiting to get out there, we can have these problems with stalk rots. So that's another thing that we have to think about. So I said that tar spot has many lookalikes, and especially very early on when you're first looking for tar spot in the field and the infection is very, very low. It's easy to get dirt, or now that we're getting into pollination, at least here in Iowa, I'm not too sure about Minnesota, but you know how that pollen can get stuck on the leaves and then it can kind of turn black and moldy as we get all those saprophytic fungi feeding on it. So that can look like tar spot. And then of course there's bug poop can also look like tar spot. And basically the rule is if you can wipe or scrape off the dark spot, it is not tar spot. So tar spot is embedded in that leaf tissue. And the last couple of days, we've had several reports of tar spot in Iowa. And one of the things that the folks who found tar spot have reported to me is that they can see the black spot on top of the leaf. And when they turn over the leaf and look on the underside, they can see a black spot, or they can see some water soaking or some discoloration or anything. So I think that that's another very good clue for looking at tar spot. If you see a black spot on the leaf, can you see something on the underside of the leaf that might indicate that this is some structure that's going all the way through the leaf? The other thing about tar spot, and this was pointed out on Twitter a couple of days ago as well, but I say tar spot bleeds. Nicole Steiklein, an independent crop consultant out in Eastern Iowa, will talk about how the spots have tails. And so I think you can see on this picture here that there's some round spots, right? But there's also some spots that have these tails, or they bleeds down the vein of that leaf. If you see something like that, that's not bug poop. That's definitely tar spot. Towards the end of the growing season, so when we were in Iowa last year, we only saw tar spot right at the end, after dent. And around about that stage of the season, you'll remember that common rust and southern rust, they stop producing those orange or reddish colored spores, and they start producing black spores that are called teleospores. And it's very easy to get those teleospores of rust muddled up with tar spot. So here in this picture of A, the orange arrow is pointing to teleospores of common rust, and all around it you can see tar spot lesions. If you look at picture B, you can see common rust lesions with those black spores starting to burst through the epidermis of that leaf. And then right at the back, right at the top of the picture, pointed out by the white arrow, that's a tar spot lesion. So remember, with the rust, you'd be able to scrape those teleospores off with your fingernail. Tar spot, you cannot scrape it off. It's just embedded in that leaf. Tar spot can spread pretty rapidly as well if you have the right conditions. And so this is a picture from Darcy Telenko at Purdue University showing a single spot that her students found in one of their research fields, and some close up. There again, you can see how it bleeds down the veins or has those tails. And this is what that field looked like 1 week later. So another thing about tar spot is if you think you find something that looks like tar spot, mark that edge of the field, that area in the field, and then go back to it a week later. And if we've had conducive conditions, which we'll get to in a moment, you should see more spots, and that'll be another indication that you're looking at tar spot. Really, if you find tar spot and you're not sure, that you should send a sample into a diagnostic clinic. So the University of Minnesota and Iowa State University both have plant disease clinics, and they're always happy to look it up. The best way to identify this is to kind of slice and dice those lesions and look under the microscope, and then we can tell for certain whether we have tar spot or not. We don't know a lot about the fungus that causes tar spot, but we presume that this is how it works. So we know that the fungus can survive in infested residue as those black spots, those stromata. And then what happens is in moist conditions, those stromata start to exude the spores in this kind of salmon pinky jelly. Those spores are probably rain splashed or spread by wind onto the leaves of corn plants where they infect. Symptoms we probably see about 14 days after infection. And of course, those new spots can produce more spores, and so we can get this repetitive cycle. As you know, plant pathologists are obsessed with disease triangles. And so if we think about the disease triangle in terms of tar spot management, we have this pathogen that is virulent, it causes disease. We know that it overwinters in the Midwest, and we know that it's endemic. And that's been proven the last 5 years. We've seen this disease every single year, which means it's endemic. And we know that the spores can move because that area is increasing. Most of our corn hybrids, the hosts, are susceptible. The susceptibility will differ between hybrids, but we don't have any resistant hybrids. And obviously, the earlier we get the disease, the more impact on growth it's going to have. Favorable environment for tar spot is cool and wet. And particularly in irrigated fields, it can be a very big problem. But we're talking about, temperatures, 65 to the low 70s and a lot of moisture. And we also really think that leaf wetness plays an important role in this disease. As we look forward into 2020, how are you going to manage how are you going to manage this disease? Well, right now, the best management is going to be fungicides, right? The corn's already been planted. If you do have a problem with the disease this year, then next year, maybe you can look for a hybrid that has presumably a little bit more resistance. But these are the fungicides that are available. There's a lot of choices that you can make. One thing we're not 100% sure of is timing of those fungicides, but we want to time those fungicides well so that they stop further disease development and they last as long as possible into that grain fill period. Right, I am going to pass this over to Dean, who's going to finish up the presentation.
Okay, hello everybody. I just want to comment a bit about the Minnesota situation. I think most of you, or many of you know, it's been found in Minnesota now too. We've watched the disease march, so to speak, across the Midwest, finally being found in Minnesota as of late September 2019, and a few more counties in October. So very, very late in the season. But we have no reason to think that it's limited to these areas. And we really want to make some effort into finding out where it is for the next year. And I do want to make the point too that where it was found in many of these places, it wasn't just a few lesions. There was substantial amounts of disease in patches of those fields. So it was on the verge of causing problems. It just probably came too late to be a real problem. Next slide. Okay, so a key thing here is, as you've seen the maps from Iowa and other states, it became pretty widespread, especially in Iowa in 2019. It spread nearly all the way to Nebraska. We didn't have anything like that we know of in Minnesota, but we also didn't have the same scouting effort out. So this year we really do want to put more effort into finding out the distribution of tar spot. And we don't know how far north it would go, how far west, but we need to find out because we want to know where it is and where it may be an emerging threat and something really to look at managing. And I want to make the point with funding from National Corn Growers and Minnesota Corn, we have some funding to support diagnostic and survey work. So if anybody from Minnesota sees samples, we can diagnose those free of charge. Please contact me first and let me know, with photos and where it is if you find anything. And so we'll be sending more information out later, but of course, as you saw, it's developing in Iowa now. There's no reason it couldn't be developing in Minnesota soon as well. So next slide. So in summary, tar spot is here in 2020. Now we don't know it's in Minnesota yet, but it's clearly not far away, both in Wisconsin and Iowa. So we really need to start looking. And based on all the past information, the severity depends on the hybrid, the weather, and the crop stage, especially when the disease starts. And so we have a lot to learn about this disease. Every state and environments can be a little different, and we have a lot to learn about the disease in every state. Again, the hybrids, as Alison mentioned, they vary in resistance. There's no such thing as a truly resistant hybrid known yet, but in looking at hybrid variety trials in some other states where the disease is developed, it was pretty clear that there are big differences in hybrid resistance or tolerance. So we'll learn more about that this year for sure. And again, as Alison mentioned, fungicides in a number of trials in several states tar spot, both incidence and severity. The timing is important, exactly when we get them on, and we have more to learn about that as well. But definitely that's one, at least temporary solution. Probably a long-term solution will be resistance. Next slide. So that concludes what we have planned for today. And I will turn it over to others to comment on, I guess, the future of this series and remind what's happening next.
All right, thank you both. We do have a few questions that have come in. Again, feel free to use that Q&A box if you have questions, and we'll get through as many as we can here before 1:30. So probably the first question came in from Minnesota. So Dean, this might be appropriate for you. Should we be scouting now for tar spot?
Yes, I think it's not too soon. I believe this is earlier than it's been seen in many places before, but it's been wet. We have in many places, as you know, a crop further advanced than we normally have at this time of the year. So I don't think it's too early. I would have thought waiting a couple weeks would have been more optimal considering a normal year, but this year's a little abnormal in some ways. We're ahead on heat units. We've got varying weather, very wet areas in some place. So I think it's not too early to look.
Okay, good to know. So we should be out looking for it now. There are several good questions here. Probably the first one that might be a burning question on folks' minds that I'll just kind of put out to both of you is, what might we expect for a yield reduction from tar spot, right? Burning question, everybody wants to know the answer.
So I heard from Marty Chilvers in Michigan, who's Dean and my colleague in Michigan, that there were some fields that lost about 60 bushels to tar spot. So that, that we're looking at a 25 to 30% yield loss from tar spot, up to.
Okay, so maybe, hopefully worst case scenario at this point,
yes.
Anyway. Okay.
Yeah, that was a very severe case.
So there are several questions that they're all different questions, but they all kind of cover what I would deem to be similar topics, talking about kind of survivability. So the first question, I guess, is there anything known about how a cover crop might affect the life or survivability of spores?
No, I am not aware of any work that's been done there on cover crops. One of the things that I can think of is that if you had enough cover crop biomass, when you terminate it, right, and you leave that cover crop biomass mulch on the surface, of the field, that would kind of prevent those spores early on in the season while you still have the mulch there from splashing up onto the corn. So I think it could be a physical barrier, but then as that cover crop residue breaks down, you're going to have less and less of a barrier. I can tell you that I do not think that rye is a host of this pathogen. So we don't have to worry about that.
Well, you must have read my mind, because the next question was, is this species of tar spot from corn found on any other grass species?
So Nathan Kluchecki at the University of Illinois has been doing some work on that. And I know that I actually just read an abstract from one of his students a couple of days ago. And basically they found that they collected tar spot from corn and then also from various grasses. So I know that there was a sample sent from Iowa from a grass and then around the state. But on all of those grasses, although those grasses had tar spot symptoms, the pathogen associated with that tar spot was not Phyllocora matus. It was another species of Phyllocora. Is that clear, Megan?
Yes, very clear. And hopefully good news, at least so far. One more question about survivability. Could you go deeper into the survivability of spores, specifically in regards to things like baling corn stalks, using them as bedding pack, and then potentially spreading them on field afterward?
That's a great question. And yeah, so I know that always comes up, and I think that we'd like to think that, you know, by using them as bedding, or that all those microbes from the manure might help break down those structures and therefore decrease the survivability of the tar spot fungus. I think that there's a chance, but then also having said that those black spots of tar spot are called stroma, or many of them are called stromata, but they're very, very tough and very leathery. They're almost like minute sclerotia, right, that you would think of it with white mold. And you think about how tough those white mold sclerotia are, and these appear to be pretty tough. So it might take a little bit more to break them down. I would be concerned if I was going to use, you know, tar spot infested corn residue as bedding. I would be a little bit concerned about putting it out on the field because it could serve as a source of inoculum.
All right, that's good to know.
Yeah, I'd like to make two comments like that, and I think that's really true, and I think also it probably survives fairly well, especially if the tissue stays fairly dry. I think some of you may have seen there was a photograph from western Iowa late last summer of a bale with corn stalks and leaves in it somewhere in western Iowa with very clear tar spot symptoms. So I suspect that is one way it can move around. And the other survival question that's come up a lot, and Alison did mention this, but do cold winters affect survival? And there was a lot of question about that initially, but I think that's been pretty clearly verified that it does survive very cold winters in the upper Midwest. So that's probably not a limiting factor.
Unfortunate, right? We go from good news to bad news really quickly. Is there any information about which fungicides might perform the best, right? We're probably going to see a range of they perform against tar spot. Do we know?
So on the cropprotectionnetwork.org website, which you have there's a link there on this final slide. We have a couple of publications, fungicide efficacy for corn diseases and one for soybean diseases. So in there, I believe that we have tar spot this year. That'll give you kind of an idea. I know that Damon Smith at the University of Wisconsin and Marty Chilvers at Michigan State University and probably Nathan Kluchecki at University of Illinois all have, they have a lot of fungicide data. And I know that those are posted on their respective web pages. If you cannot find it with a Google search, then please feel free to email me and I can send you the link to that information.
Perfect. And we can actually put that link into that SciBox folder that I linked to. So it'll be in the tar spot folder for everyone to access. All right.
And I would add that Darcy Tolenko at Purdue also has fungicide efficacy data for tar spot from Indiana, which I believe is available on a website they have as well.
Okay.
Perfect. Okay, we have, I think, too many questions to answer in the time that's left, but a few of these are, again, they're kind of all in the same realm of this whole survivability question, right? So how important is crop rotation? Would we expect it to be more severe on corn? If we take, one of those cornstalk bales, perhaps that has some stroma on it, and we rotate to beans, will it still be there the next time we go to corn 2 years later, more than a year later? And then no-till versus tillage, right? All of these questions about survivability and how that's going to affect it.
So, I mean, I would treat tar spot the same as any corn disease, right? So we know that corn on corn often leads to more severe gray leaf spot, more severe northern corn leaf blight. But those pathogens can also blow in from neighboring fields, right? So I think that tar spot's exactly the same. We know that tillage, tillage bearing that residue, reducing the amount of residue in the land is going to reduce the amount of inoculum that you have for gray leaf spot and northern corn leaf blight. And I suspect it's the same for tar spot. I know that we've talked about survival. What if you rotated to soybean and then you went back into the field and there's no residue? Do you still have the tar spot fungus there? And that's a question that we really don't know at the moment. I mean, I mentioned that those stromata are very tough. And so it's possible that they could survive, 18 months. Throughout the soybean and then into the corn, but we just really don't know. So for the moment, I would just think about tar spot as, similar to gray leaf spot, northern corn leaf blight, Goss's wilt, those foliar diseases that we tend to struggle with in our areas. Dean, you have anything to add?
No, I think that summarized it pretty well. There's a lot we don't know about this fungus, this pathogen, and how well it survives under different conditions.
All right. Oh man, people are putting in questions right now. So if you have any questions that I don't get to, please feel free to email myself. You can email Allison or Dean directly. Their email addresses are right here on the screen for you. One more question is there a growth stage late enough that plants will not be affected by tar spot? Or perhaps I would change that to say, is there a growth stage late enough where if we find it, we wouldn't need to worry about trying to treat for it this year?
Yeah, that's a good question. I would say we struggle with that with a lot of diseases. Last year in Iowa, I mentioned that we started to find it around about dent stage. And even though it was pretty easy to find by the time we got to physiological maturity, I don't think that the amount of tar spot that we had there really impacted yield too much. So, or even at all. So, yeah, I mean, dent, but it's hard to say. I mean, the earlier that comes in, the more damage it's going to cause. And we don't really have a lot of data to say, well, what happens if it comes at R3? I think one of the things, sorry, I'm taking so much time, is that a lot of people are spraying fungicides now, right? And they're getting in at VT, you know, R1 and spraying those fungicides, and that's actually keeping us clean until R5. And so, yeah, it's kind of hard to know if something came in at R3, did it really affect yield very much? Tough question.
Yes. So maybe we're just a little over time, but maybe the last comment you could make is if somebody finds a plant or they find some leaves that they think has tar spot, what would be the procedure that they should take in order to ensure that they, you know, that those stroma actually make it to the lab correctly to get identified?
Those stroma are pretty tough. So what I would suggest you do is just what I did when I was sending leaves to Darcy, for example, out in Indiana, is we would just take the corn leaf, just flatten it between a couple of pages of newspaper, you know, just to make it nice and flat. Just put it in a envelope and then just stick it in the mail and mail it across to her. So those structures are really tough, and when we cut through them, we can see the spores inside of those structures, and just the shape of those structures is enough. So it's pretty tough. You don't have to be too gentle, I don't think.
All right, but don't add moisture to it.
No, do not add moisture, because then we just get a moldy mess.
All right. Well, we had a couple other questions, but we are over time, so please feel free to email Allison or Dean with those questions. I know a lot of them were in similar, everybody wants to know about survivability, what happens with rotations and things. It looks like Angie has put in some links directly to these efficacy, fungicide efficacy
Thanks,
resources,
Angie.
and we will actually put those in that SciBox folder for everyone. Please self-report your CEUs. We have information about that in the SciBox. And finally, again, I'd like to thank our sponsor, Iowa Corn Growers, my colleagues at the University of Minnesota, and thank you, Dean and Allison, for your expertise today. This has been fantastic.
Thank you for having us.
Thanks everyone for joining. Come back later this week on the 16th. We'll have soybean aphid IPM, and then next week we'll talk about corn rootworms and gall midge.